Hello, everybody. Today's lesson is on investigating symmetry, section 2.4 in our geometry text. It's going to be on page 101 if you're following along in your book. And so there are two different types of symmetry that we're going to look at today, and that is line symmetry and rotational symmetry. So line symmetry is when you can draw a line such that the left half and right half of the line are exactly the same, meaning when you fold your paper on that line, that one side folds exactly on top of the other. So here I have an equilateral triangle drawn on a piece of tracing paper, and we can get a line of symmetry by folding. We can see if it has a line of symmetry if we fold one half so it lines up perfectly with the other. See, I'm matching up the parts of the triangle and then creasing here. And when I open that up, I see that I have two identical halves. It goes right through the vertex here. And when I fold one onto the other, it matches all along that line. Okay, and so this triangle definitely has one line of symmetry. We could try turning it this way and doing the same thing. And so then if I fold, you get those vertices to match up and sides to match up, and fold there. Then I have another line of symmetry. So the left and the right half of that line are exactly the same. And then I'll be able to do one more here. So again, I'm trying to match up those vertices and then crease there. And now I have another line of symmetry. And so this triangle has three lines of symmetry. That one, and that one. Not all triangles have three lines of symmetry. Some don't have any at all. The one that's in our textbook here only has one line of symmetry. If I tried to draw a line like this, this half and this half are not the same, and there's not really any place that I can draw it. If I try to draw it at an angle like that, still this piece and this piece are not the same. And so this triangle only has one line of symmetry because it's an isosceles triangle, not an equilateral triangle like the one I did here. To take another look at line symmetry, there's an applet here, which you can follow along with on my website. If you go to our assignment listing, our calendar, our course calendar, I have three links over here. We're going to start with the first one called Line Symmetry Applet, and so that looks like this. And so this is an exercise to see if we can find the line of symmetry for each of these, and it says in the directions each shape has a line of symmetry and only one, and so we want to move this to where the line of symmetry is. So if I move these endpoints, it will let me know when I have it in the right place. So clearly those halves are not the same, but if I put it right there, as soon as I get it in the right location, it turns green. So here's a good example of a figure that has exactly one line of symmetry, okay? And then, so you could follow along with, you could do these on your own if you want. That would probably be more beneficial for you to do it on your own. So you could pause your video and click on this first link here on my website. It says Line Symmetry Applet. Click on that and then go through all of the exercises here. So you can go ahead and pause your video, try that out, and then come back here when you're ready to move on. The next one, this is like the one in the book. It only has one line of symmetry. If we move it like this, that works. If we try to move the line over this way, it never turns green. There's no location where the two halves are going to be equal. Okay, and so the only place it works is right down the middle, vertical like that. This one might have been a little tricky for you. There's nowhere around here that it'll work, okay? But if you put one vertex there, there is a line of symmetry. So this triangle has only one line of symmetry as well. This one I'll bet was pretty easy for you. Just like that. And this one, let's see, is like that. How many lines of symmetry do you think this one has? There's one. What about if we do it this way? That would be a line of symmetry also. They didn't mark this one, but it looks to me like that top half and bottom half would be the same. So this figure actually has two lines of symmetry. They only made one of them turn green, and that's the vertical one. But it actually does have two lines of symmetry. And the rest of those you can explore. If you keep going, you get to, excuse me, if you get far enough, you get to section B, where these ones, not every shape has a line of symmetry, and they want you to select the one that does have line symmetry. And so only one of these does, and it is, in this case, actually I see two of them. This one has a line of symmetry. It would be like this. Okay, so that works. This one also has a line of symmetry diagonally. Yes. The other ones do not have line symmetry. There's nowhere where you can draw a line. If I try clicking on that, it says nope. If I try clicking on this, it says no. But these two do have line symmetry. And this one has many, like this. Like this. Like that. And like that. Okay, so that's all there is for that exercise. And then moving on to the next type of symmetry, which is rotational symmetry. Rotational symmetry is when you can turn a figure some measure less than 100 or less than 360 degrees and have it look exactly the same. And so this first applet, the rotation applet number 1, does a good job of demonstrating that. So here I have an equilateral triangle, and so watch the red corner. When I turn this figure to there, it looks exactly the same except for the red corner. So that that's what we're looking for rotational symmetry. Now, how far did it turn? Turned 120 degrees to get there. And then I can turn it again. And when I'm at 240 degrees, if I can get it to stop right there, there it is, 240 degrees, it looks exactly the same. And then all the way back to 360, it looks the same. But 360 degrees doesn't mean we have symmetry. It's got to be something less than 360. So we would say this figure has rotational symmetry, and we would say it has 120 degree and 240 degree rotational symmetry. Okay. The next one, a rectangle. How far do you have to turn this one? So to see if you can guess before I do it, how far do you have to turn this one so that it looks exactly the same? Still doesn't look the same. Still doesn't look the same until you get right there. And that, if you look at the angle down at the bottom of the screen, says that's 180 degrees, and that makes sense. So that's starts there, and it has to go a full 180 before it looks the same, and then 360. But again, remember, 360 doesn't mean you have symmetry. So we would say this figure has only 180 degree rotational symmetry. We'll never say 360. If a figure has to turn all the way around, then it doesn't really have rotational symmetry. So this one has only 180 degree rotational symmetry. And then the next one is the Pentagon. So try to anticipate how far will I have to turn this, and how many different angles can I turn it so that it matches up. Okay, every angle in an equilateral pentagon is 108 degrees, but that's not the measure that's gonna work for you. So just think about what we did with the triangle. The triangle was, remember, 120. There are three sides to a triangle. 360 divided by 3 is 120. So we did 120 and then another 120. Okay, which gave us 240. Okay, so the Pentagon, what do you think this one will be? So the key is to look in the center here. There are 5 angles in the center because of the 5 sides. So 360 divided by 5 is 72 degrees. So watch this. If I turn this figure 72 degrees, it looks exactly the same. If I can stop, there we go, at 72, it looks the same. Then I go another 72, so that's 144. Then another 72, that's should be 220, 216. And then another 72 puts me at 288. And then the last one would bring me back to 360, which we know doesn't count. Okay, so it's multiples of 72. What I'd like you to do now is go back to my website and click on the third link that's here, the one that says Rotation Applet number 2, this one. So click on that link, and that'll take you to this. And what I'd like you to do is make a prediction before you touch anything for each of these figures. How many degrees of rotational symmetry do you think it has? And you might say some of them have no rotational symmetry, because remember, if you have to spin it all the way 360 degrees, that's not rotational symmetry. Okay, the first one should look familiar because we just got done doing it, and so you should already know the answer for that one. But look at the other ones and see if you can make a prediction, and then drag the slider going through one shape at a time and see if you can get the correct answers for each one. So pause your video, try out this applet, and then press play when you're ready to continue. So this one, we said the Pentagon, we said, has 72 degree, 144, 216. Let's see, we had 72 plus 72 plus 72 is 216 plus 72 is 288. So those are the 4 different types of rotational symmetry that the Pentagon has. And then the second figure has only 180-degree rotational symmetry. We can see that in the applet. If I move the slider, we're just watching image 2 right now, the second figure, and I have to turn it all the way to there to get it to line up, and that's at 180 degrees. Okay, so that's the only type of symmetry that that figure has. This one, the image 3, is kind of like an equilateral triangle. It's got 3 congruent branches to it, and so it's going to be just like the equilateral triangle. It's going to be 120. So there's our first match. If you're watching image 3, is 120, and then it'll match again at 240, and then it won't match again until 360. Okay, so that has 120 and 240. So this one has 120-degree rotational symmetry and 240-degree rotational symmetry. Image 4, it only has 180-degree rotational symmetry. If we take a look at the applet, there it matches at 180, and it doesn't match again until 360, so it has only 180. Okay, and then image 5 actually has no rotational symmetry because it doesn't match up until I go all the way around 360. So if you have to go all the way around, then that figure doesn't have rotational symmetry. So image 5 has no rotational symmetry. It has line symmetry, but not rotational symmetry. Okay, so on page 103, there are 3 figures here. See if you can figure out on your own how many degrees of rotational symmetry each of these figures has, and it might have more than one type of rotational symmetry. So write down all of the angles less than 360 that give it rotational symmetry. So pause your video, try filling in all 3 of those blanks with as many numbers as you can, or you can say that there's no symmetry. Pause your video and finish that up, and then press play. So this first figure has 90, 180, and 360, sorry, not 360, 270. 90, 180, and 270-degree rotational symmetry. It helps sometimes to draw the lines from the center, and we see that there are 4 equal parts. So 4 equal turns, 360 divided by 4 is 90. Okay, and then the second figure has no rotational symmetry. There's not any, you have to turn it all the way around 360 to get it to match. And then this arrow figure, if we just flip it a half a turn like that, it matches, so that's 180-degree rotational symmetry. So those are the 3 answers for those problems. And now some figures have both line symmetry and rotational symmetry, so that's what we're going to do in the next couple examples. So describe the symmetry of each figure. So this figure has rotational symmetry and line symmetry, so we want to try to draw as many lines as we can. So there would be 1, 2, 3, 4 lines of symmetry. And if we turn it just 90 degrees, then it matches up, and then we could turn it another 90 and another 90, and it would continue matching up. So this would have 90-degree, 180, and 270-degree rotational symmetry. So it's got 4 lines of symmetry and 90, 180, and 270-degree rotational symmetry. Okay, and then example B, they give you this figure. So go ahead and pause your video and try out B, and then press play when you're ready to see the solution. All right, so this figure has 3 lines of symmetry. And there are 3 different pieces coming off of the center. So if you do 360 divided by 3, you get 120. So this is going to have 120 degree and 240 degree rotational symmetry. And more of the same thing on page 105. Let me have you, let's see, we already did one like 6. So try 7 and 8. Fill in, do your best to fill in those blanks there. So pause your video and try 7 and 8, and then press play when you're ready to see the solution. Figure 7 has only line symmetry, because you can draw a line there, but even if you turn it 180 degrees, it doesn't match up. It would point this way when you turn it 180, and so you'd have to turn it all the way around 360. So there's one line of symmetry, and there are no angles of rotational symmetry. Number 8 is a tricky one because of these little tails that hang off the sides. It doesn't have line symmetry. So you might think that it has line symmetry, but if you folded it, if you traced this with tracing paper and folded it, you'd end up with a little piece sticking out here, like that. And so that's not a line symmetry. You can draw another line over here that looks like line symmetry, but then when you fold it, then you get that little tail sticking out there that didn't used to be there. So they don't look exactly the same when you fold them across a line. And so there's no line symmetry, but if you turn this figure clockwise or counterclockwise, the tails point in the same direction, so they all match up as you turn them. So it only has rotational symmetry. There's no line symmetry. And the angles are, since this has 5 parts coming from the center, that's going to be 360 divided by 5, which is 108. 360 divided by 5 is 72. So we have 72, 144, 216, and 288. Those are the 4 different types of rotational symmetry that we get. All right, and that's it for today's lesson. So you can go back and watch any of this again if you need to. You can go back to those applets that are on my website here. Those 3, not that one, this website, these 3 links to the applets, and that'll help you get a firm understanding of what the different types of symmetry are. Have a great day, everybody.